Students, welcome to lecture series of Mathematics 1. This is Maclaurin, Assistant Professor at LG Institute of Engineering and Technology. Today we will discuss new topic, that is Maclaurin's series by differentiation and integration. So here we will have to find out Maclaurin series with the help of differentiation and integration. So let us discuss example. First example, that is we will have to find out Maclaurin series of function f of x is equal to sin inverse x. So here, first of all, we will have to take derivative of this function. So differentiating both sides. So here d by dx of f of x is equal to d by dx of sin inverse x. Okay, and derivative of sin inverse x. Derivative of sin inverse x is 1 divided by under root 1 minus x square. Okay, this is the formula for derivative of sin inverse x. Now this can be written as 1 minus x square whole raised to minus 1 by 2. Okay, now here we will use binomial theorem, and using binomial theorem we can write down 1 plus x whole raised to n is equal to 1 plus nx plus n into n minus 1 divided by 2 factorial x square plus so on. Now if we compare 1 minus x square whole raised to minus 1 by 2 with 1 plus x whole raised to n, then value of n will be minus 1 by 2 and x will be minus x square. So here replacing n by minus 1 by 2 and replacing x by minus x square. So here it will be 1 will be as it is plus minus 1 by 2, and what is x? It is minus x square plus minus 1 by 2 minus 1 by 2 minus 1 divided by 2 factorial, and value of 2 factorial is 2. Then here instead of x we will write minus x square whole square plus so on. So if we simplify this, then it will be 1 plus, this will be minus into minus, so it will be plus, so x square by 2 plus, here it is minus 1 by 2 and here minus 1 by 2 minus 1, so if we take LCM then here it will be minus 1 and minus 2, so minus 3 by 2. Minus 3 by 2 into minus 1 by 2, so it will be 3 by 4, and it is divided by 2, so it will be 3 by 8. 3 by 8 and minus x square whole square, so it will be x raised to 4 plus so on. So here d by dx of sin inverse x is equal to 1 plus x square by 2 plus 3 by 8 x raised to 4 plus so on. Now here we will take integration both sides, because we have to find the Maclaurin series of sin inverse x. So for that, taking integration both sides, so integration here and here it is derivative, so we will get same function, that is sin inverse x. So here if we integrate both sides, then here it will be sin inverse x. Then integration of 1. So integration of 1 with respect to x is x. Okay. Plus, then here integration of x square. Now what is integration of x square? It is x cube divided by 3. because as we know that integration of x raised to n is x raised to n plus 1 divided by n plus 1. So it will be x cube divided by 3, and here it is into 2. So it will be x cube divided by 6. Okay. Plus here again integration of x raised to 4. So integration of x raised to 4 will be x raised to 5 divided by 5, because integration of x raised to n is x raised to n plus 1 divided by n plus 1. So if we simplify this, then it will be 3 x raised to 5 divided by 40 plus c plus so on, where c is a constant. Now here we will have to find the value of constant c. So for that we will replace x by 0. So here if we replace x by 0, so here sine inverse 0, okay, is equal to, here it will be 0, here it is 0, and here it is 0, and all other remaining terms will be 0 because those terms contains x. Okay, so here it will be c, and we know that sine inverse 0 is 0, therefore value of c is equal to 0. So if we put value of c equal to 0 in this series, okay, then Maclaurin series for sine inverse x will be x plus x cube by 6 plus 3 x raised to 5 by 40 plus so on. So this is Maclaurin series for sine inverse x. Now let us discuss second example of function cos inverse x. So here we will have to find out Maclaurin series for cos inverse x. Okay. So we can find out by using same procedure, by taking derivative, then using binomial theorem, then taking integration both sides. So we will obtain the series of cos inverse x. But as we have already obtained the Maclaurin series of for sine inverse x, so we can directly use this result, which is sine inverse x plus cos inverse x is equal to pi by 2. Okay, so therefore cos inverse x is equal to pi by 2 minus sine inverse x. So we know the Maclaurin series for sine inverse x, which is this, so we will put this series. So here it will be pi by 2 minus, now all terms will be negative because of this minus, so minus x cube by 6 minus 3x raised to 5 by 40 minus so on. So this is Maclaurin series for cos inverse x. Now let us discuss third example. Find Maclaurin series for function f of x is equal to log sec x. So here we will have to find Maclaurin series of this function, that is log sec x. So first of all, taking derivative both sides, so here it will be d by dx of f of x is equal to d by dx of log sec x. Okay, and as we know, the derivative of log x is 1 divided by x. So here it will be 1 divided by sec x, and here if we take derivative of sec x, then derivative of sec x is sec x into tan x. So here into sec x into tan x. Okay, so here sec x cancel out, so finally it will be tan x. So d by dx of log x will be tan x. Now here, as we know the Maclaurin series for tan x that we have already obtained. Okay, so Maclaurin series for tan x is given by x plus x cube by 3 plus 2x raised to 5 divided by 15 plus so on. So this is Maclaurin series for tan x. Okay, and this is what it is, d by dx of log sec x. Now we will have to integrate both sides. If we integrate both sides, then here integration and here it is derivative. So we will obtain this function, that is log sec x, which is our given function. So that's why integrating both sides. So here integrating both sides. So here it will be log sec x is equal to, okay, integration of x. So integration of x will be x square by 2, because integration of x raised to n is x raised to n plus 1 divided by n plus 1. So by that formula it will be x square by 2. Clear? Plus, now here again integration of x cube. So integration of x cube will be x raised to 4 divided by 4. Using same formula, integration of x raised to n is x raised to n plus 1 divided by n plus 1. So if we simplify this, then it will be x raised to 4 divided by 12. Okay. Now here integration of x raised to 5. So using same formula, integration of x raised to n will be x raised to n plus 1 divided by n plus 1. So integration of x raised to 5 will be x raised to 6 divided by 6. Okay. So here if we simplify, then here 2x raised to 6 divided by 90. So this can be written as x raised to 6 divided by 45 plus c plus so on. Now here we will have to find the value of this constant c. Okay. So for that we will have to replace x by 0. So here replacing x by 0. If we replace x by 0, then here it will be log sec 0. So here it will be log sec 0. And here it will be 0, here it is 0, here it is 0, because x is equal to 0. And all other terms will be 0, because all other terms contains x. Okay, so here on the right hand side we will have only c. Now we know that value of sec 0 is 1. Okay. So here it will be log 1, and so c can be written as log 1. Okay, and we know that value of log 1 is 0, therefore value of c is 0. Okay, now putting this value of c in this series. Okay, so if we put this value of c in the series, then Maclaurin series for log sec x is equal to x square by 2 plus x raised to 4 by 12 plus x raised to 6 by 45 plus so on. So Maclaurin series for log sec x is equal to x square by 2 plus x raised to 4 by 12 plus x raised to 6 by 45 plus so on. So in this lecture we have discussed topic which is Maclaurin series by differentiation and integration. So first example that we have discussed is of sin inverse x, then second function was cos inverse x, and third function is log sec x. Thanks for watching this video. I will see you in the next lecture.